This is a tutorial on how to solve polynomial equations, and we've got this fourth degree polynomial that we're trying to solve. And step one for me is to look at the graph and see what I can determine from that. So I'll go to the graphing calculator, and I've already got this entered in as y equals. When I look at the graph, I can see I have two real solutions on here. And maybe there's some further to the left and the right that aren't showing up on this window. I'm not sure yet, but I see at least two, and they're both positive. That's going to help me in this next step. I'm going to go to the table and have delta table be 1. And what that does for us is it gives us all of the x values that are integers and their corresponding y values. One thing that I notice is that between the x value of 1 and the x value of 2, the y values go from positive to negative. So there's something in there, although it's not an integer. I can scroll down further in the positive direction because I saw those points on the graph until the point where I see that when x equals 7, y equals 0. So there is going to be one solution of x equals 7. Because our leading coefficient is 14, I know that we could have rational numbers that have a denominator of 14 or 7 or 2 because those are all factors of 14. So to find those, I'll go back to the calculator again and change my delta table to 1/14. Second window is the table start, or the table setup. I always want my table start to be at 0 to make sure it doesn't get off at all. And then delta table, I'll type in 1 divided by 14. I can go back to the table again. And notice there's a lot more x values in here, and there's a lot of decimals. What these stand for, since delta table equals 1/14, is all the fractions of, first of all, 0, and then 1 out of 14, 2 over 14, 3 over 14, and so forth. 4, 5, 6, 7 over 14, 8 over 14, 9 over 14, 10 over 14, 11 over 14, 12 over 14, 13 over 14, 1. So I was able to count all the way through, and I did see that there was change from positive to negative when I looked at it the first time with just the integers, and now I can see, okay, well, here is that point where y is 0. So I'll just go back and count 1 over 14, 14 over 14, 1 and 1/14, 2/14, 3, 4, 5, 6/14. This number represents 1 and 6/14. 1 and 6/14 would also be simplified down to 1 and 3/7, or 10 over 7. So there is another one of our zeros. We have two of them now, and it 2 out of our 4 total solutions, and I know there's supposed to be 2 more. So what we can do at this point is use synthetic division to simplify the original solution. So we have 14x to the 4th minus 118x cubed 490x squared minus 2,950x plus 3,500. And since the number 7 worked, we'll put 7 on the outside. I'll go ahead and pause and do this one off camera. So using synthetic division, I got these coefficients at the bottom, and most importantly, we got a 0 at the end that confirms, yes, 7 does work. Now I'll do this process again, and since 10/7 was a solution, we'll put 10/7 on the outside. Go ahead and pause it again and work through this. And then using synthetic division, we get these coefficients at the bottom, which now don't stand for 14x to the 4th or 14x cubed, but 14x squared plus 0x plus 350. We're trying to find the 0, so we're going to set this equal to 0 and solve it. We have 14x squared plus 350. When does that equal 0? Good news is I can divide both of those terms by 14. It doesn't change anything. It just gives us smaller numbers to work with. And x squared plus 25 equals 0. I can subtract 25 from both sides, take the square root of both sides, plus or minus 5i, which is kind of what I would expect based off of the graph that I saw earlier. I saw 2 real solutions on the graph, and I knew there were going to be a total of 4, which means my other 2 solutions that aren't showing up on here would be complex numbers, those imaginary numbers. So to finish this one off, what are the solutions? My solutions were x equals 7, 10/7, positive 5i, and negative 5i. Let's look at one more example of solving a polynomial equation. trying to find the zeros of this one. It's fifth degree, so I believe there should be 5 solutions. I have it entered into the calculator already. Here is the graph. Looks like there is a negative value, another negative, there's a positive value, and another positive value. It looks like this is the only integer value, and it sure looks like it is x equals 1. And it's kind of hard to tell on the graph. I could zoom in a little bit more, but it looks like it is also a bounce point. So when I'm doing this, when I'm going to check to see if x equals 1 is actually a double root, we'll go back here again, expand the calculator. We'll look at the second table, x equals 1. Sure enough, there's a 0 there, so I believe that x equals 1. And I think it's a double root, so what I'm going to do right at the beginning is use synthetic division to simplify this down and to check out to see if I'm accurate with that. So I'll go ahead and pause while I do this synthetic division off screen. On the synthetic division twice now. With the number 1, it worked both times, which means that 1 is a double root. I don't have to write it twice, but by writing it twice, that makes me realize that I've found 2, and there's 3 more solutions to go. Going back here again, I can see that between x equals 4 and x equals 5, it switches from a negative to a positive, so there has to be a root in there. And the leading coefficient is 2, so I'll go back to the graphing calculator and change the delta table to 1/2. Second table set, I always want it to start at 0, and now delta table will be 1/2. We'll look back at the table again, and I'm going to scroll down. And so there is one of the solutions between between x equals 4 and 5. I thought there was a root. It's right here at 4.5. Since delta table is 1/2, and if I'm not good with fractions, I know this would represent 4, 4.5, 5, 5.5, and so forth. So this answer is 4.5. Go back and write this answer is 4.5 or 9/2. And since it originally was x to the 5th, x to the 4th, that means that this is x to the 3rd. And if I do synthetic division with 9/2 on the outside, it'll reduce it to a quadratic, which I can then solve. So off screen again, I'll do this synthetic division. The result of the synthetic division yields these numbers at the bottom. They're all divisible by 2, so I'm going to divide them by 2 to get 1x squared plus 6x plus 3 equals 0. That won't factor, so I'll go to the quadratic formula. -6 plus or minus the square root of 6 squared minus 4 times a times c, and that's all over 2a. If we simplify this just by a little bit, the discriminant, that's 36 minus 12, which makes all of this then equal to 24. The square root of 24 breaks down to 2 square root of 6. And now we have 3 terms. There's 2 terms in the numerator, 1 term in the denominator. We can divide all of those by 2 to give us -3 plus or minus 1 square root of 6 all over 1. And now we have the 1, 2, 3, 4, 5 solutions.